So I have the honor, and I'm absolutely delighted right now to introduce Dr. James Green. Jim is the chief scientist for NASA. I also, by the way, want to welcome Dave Draper, his deputy, who is with us as well here. Jim served, in addition to or prior to his role as chief scientist for NASA, he served as director of the Planetary Science Division within the Science Mission Directorate for a decade. And during which time he oversaw the creation of the NASA Lunar Science Institute, which became CERVI. So we know each other well, and I count Jim as a good friend. And before that, he was at Goddard Space Flight Center. His background is in heliophysics, and his talk is entitled Our Rare Moon. So Jim, over to you.
Thank you very much, Greg. Let me go ahead and bring my slides up. All right, and start them. Here we go. Okay. You know, this has really been a fantastic era, you know, with over 4,500 exoplanets have been found, but no moons have yet been uncovered. But we do expect that to change in the future. The discovery of exomoons around terrestrial exoplanets will help determine how rare they really are or common, providing us an understanding of how special our moon may really be. Now, one of my favorite books in astrobiology is by Peter Ward and Don Bromley. It's Rare Earth. And indeed, they propose that our moon plays a number of critical roles in keeping the Earth uncommonly habitable. Since it provides lunar tides, it stabilizes the Earth's spin axis, and it slows the Earth's rotation rate down. All believed to be important for the development of complex life. It has made us what we are today, the inquiring species that is enabling us to look back at the moon to determine what will be our future. In other words, I think Don's book and Peter's book should really have been called Rare Moon. In fact, we know the moon is a witness plate for the bombardment history of the inner solar system, but can it provide us with more details? And we resoundingly realize, yes. It enables us to understand perhaps that early Earth-Moon evolution, let alone as we, with the Artemis program and others joining us to go to the moon and explore, will be a key location for us to launch into discovering much more about our solar system and learning to work on planetary objects. Well, the moon has provided us a number of stabilities. Here are the Milankovitch cycles. The key one that changes our climate on a regular basis. The eccentricity of our orbit changes due to the pull and tugs by Jupiter. We have the precession of the equinox. The moon is intimately familiar with making the Earth tilt axis stable, moving it only from 22 degrees to 24.5 degrees. And even that makes major changes in our climate. When we look at other planets that don't have, indeed, a stabilizing moon like Mars, the obliquity of Mars is absolutely enormous, as shown here over the last 10 million or so years, varying from 48 degrees to 15 degrees, whereas you also see that the Earth's axis is, and its obliquity is incredibly stable. Some of the new research that has gone on in terms of studying the lunar samples that have come back has really been able to tease out that magnetic history of the moon, showing us that perhaps the moon generated internal magnetic fields that created magnetospheres early on, which rapidly then decayed at about 3 billion years ago. Now, this has allowed researchers to really take a look of what that magnetosphere might look like as it couples to our own magnetosphere in the early Earth formation period, as the moon was created outside the Roche limit from the giant impact hypothesis, and then began to move ever increasingly away. But while it had a magnetosphere, it had an opportunity not only to protect the Earth once again, making it uncommonly habitable, perhaps, along that theme, but allowing through connected field lines for evaporated atmosphere coming from the Earth to the moon to be stored in its polar regions. Also, new results indicating, as we look at the polar regions and the possible hydroxyl or water content and the oval shapes of that we see in both northern and southern hemisphere, has been put together as an understanding of perhaps the tilting of the lunar axis over time due to the late heavy bombardment and magma moving out and filling in, creating the mare, changing the mass distribution and tilting the axis perhaps by as much as 8 degrees. In addition to that, this is also an era for which perhaps as this intense period of bombardment and then volcanic release of gases building up an atmosphere perhaps as large as 10 millibar, which is even larger than the current moon's or current Mars's atmospheric pressure. We need to tease these things out to find out how they really occurred over time. In addition to that, the Laddie observations, as it looked in its low lunar orbit for a variety of dust, but also the final outgassing of the moon that continues on, it sees these water signals that have been traced, of course, to micrometeors that have been impacting the moon and creating these clouds of water, which then, as they get ionized, are pulled away, or as they are able to move to cold traps, end up once again in our permanently shadowed regions. So with these new findings, what can it tell us? What is the history of the early Earth moon? May it look like this? We can perhaps uncover it by going into these permanently shadowed areas, both in the North and South poles, coring down and really teasing out this volatiles evolution that we believe has been occurring. So perhaps we'll see the early comet and asteroidal volatiles that happened in the very early stages of the solar system. Then again, the lunar atmospheric volatiles. How much did the moon outgas during that time? With connected magnetic fields, perhaps volatiles from the Earth. Nitrogen, oxygen. We know nitrogen is also embedded in the regolith. We have found that before, and we therefore think that there's been some sort of communication between Earth atmosphere and the moon. Perhaps the magnetic field really enabled that. And then, of course, for the last several billion years, 3 billion years or more, the lunar water cycle from micrometeors. Now, all this will be mixed up, as we know, the bombardment history of the moon and micrometeors, the constant gardening that are going on. But if we're able to get into these permanently shadowed regions and core them in such a way that we're able to at least tease out some of these elements over time, then the new secrets about our early evolution of the Earth and the moon can be revealed. But it doesn't stop there. In reality, the moon is a major part of our future. As our programs are now moving, more humans will be exploring beyond low Earth orbit. We want to be able to stay on the moon for longer periods of time than the Apollo. We want to be able to build infrastructure. We have the opportunity in really utilizing the resources that we're finding on the moon to build fuel depots, or to be able to mine and manufacture in the area and begin to learn to live and work on a planetary surface. So the moon as rare as it might be, is really there as a stepping stone for our future, but also illuminating all its secrets for us to determine about the past and how we became uncommonly habitable here on Earth. Thank you very much.
Wow, Jim, thank you. That was outstanding. How lucky we are to have both you and Dave Parker introduce this conference and provide that kind of a perspective. And the moon, of course, is interesting in its own right. That is what a large part of this conference is about. But to link it with us in such a direct way is just wonderful. So thank you very much. And let's since we do have at least 3 minutes before our scheduled next speaker, let's take a bit of time for questions. And I think probably the easiest would be to put it in chat, and then either Mahesh or I can read the question. So let's do that. So one question is about the Gravity Assist podcast, and that's for you, Jim. Asking whether you host that. If you want to say a word.
I do. Well, thanks so much. Yes, several years ago, I had an opportunity to work with NASA Office Communication to explore a new medium in podcasting, and so Gravity Assist has been one of the most popular podcasts NASA has, and we're going into our 5th year. And this year, we're looking under the hood at NASA, talking to people that are behind the scenes that are really making the spectacular missions and activities happen. And it's really been a delight to do. So I hope you enjoy it. Thank you.
Great, thanks. And here's another one from Simone Dell'Agnello. Let's see, great talk. Interesting how differently the obliquity of the moon impacts the Earth as opposed to Mars, Phobos. Can you comment on Phobos and Mars?
Well, the Japanese will be our first great attempt to go to Phobos and bring back a sample. Their mission called MMX, this is the Martian moons exploration mission, will both visit Phobos and Deimos, orbiting them for a period of time, but then setting down on the surface and bringing back samples. And we need those to really understand whether they're debris left over from accretion of Mars, or impacts that have put material in the equatorial plane that have pseudo-accreted into these small objects. Phobos and Deimos are 20 kilometers or less. Or are they captured asteroids? And so the sample return mission will really tell us. But they're not anywhere near what our moon does for us.
Yeah, that's for sure. So let's see. Here's one from. We'll take 2 more questions. Here's one from Carolyn Vander Bogert, who I want to note is, as Mahesh said, is one of our SOC co-chairs responsible for this conference. So for both Dave and Jim, and let's maybe start with Dave on this one. Do ESA and NASA have plans to collaborate with the Chinese Space Agency on their International Lunar Research Station?
Oh, thanks. Yeah, it's a great question. So I guess we've been talking to CNSA for more than the two years on the International Lunar Research Station, discussing possible collaborative opportunities. I can say that nothing concrete has emerged yet, but there are some European payloads that may fly on Chang'e 6, and that may lead to some engagement of ESA in that particular mission. But again, nothing has been decided. It's a little bit up to our member states. I always have to explain that what I want to do is irrelevant. It's what our 22 member states want to do that is the final decision-making body. So yeah, watch this space.
Yeah, relative to NASA, we have, of course, legal restrictions working on a bilateral basis with the Chinese, but we have no restrictions working with them in a multilateral setting. And indeed, the restrictions bilaterally are such that we define our interactions with them, and then once approved by the administration and Congress, then we execute them. And we have done that on a number of small activities with the Chinese directly.
Great. Thank you both. And then let's take one last question, even though it'll make us a minute or two late. And that's to Jim from Clive Neal. What is your vision for making human exploration of the moon sustainable?
Yes, the sustainability part of it is really critical. And we must really think about a capability where humans can actually live there. So that means what do they take? What they take must be reused, how they can shape the environment to then support their activities there. Things like we would use with 3D printing, the ability to create an environment where we can land and then be able to move to a habitat, be able to grow food on the moon. The concept of starting that process of learning to grow food on another planet and then be able to harvest that. The moon is close enough that we can be supplied with food over periods of time, but we'd be remiss not really moving briskly in that particular area, because going to Mars will depend upon the ability to really grow much more food to create a sustainable activity. All kinds of life science investigations we want to be able to do. We know how humans survive with our microbial support, microbes in gut microbes in astronauts on space station change. I assume they'll change on the moon, and how will they? And can that be important in terms of eliminating toxins and other things that are different in that environment than home? So there is a whole variety of things that we have to do research in these areas to really create a sustainable working relationship on the moon to then begin the process of bringing in more heavier manufacturing, much more concepts about building larger structures, and using the moon as a vantage point to then continue on exploring the rest of the solar system. So it really provides and is a key location for us. We are so lucky to be able to have it there outside the huge gravity well of the Earth. We have a lot to learn by going there. We need to do it.
We sure do. We sure do. All right. Well, on behalf of our 225 participants right now, let me thank both you, Jim, and you, Dave, for fabulous talks. Thanks again for opening the conference in such a wonderful way and being accessible to everyone. Really, really appreciate both of you being here. Thank you.